Hello again, everyone. Today we're going to move on to the next lesson in the organic unit. But first, let's do a little bit of practice. So why don't you take a second and copy these down on a piece of paper and answer the questions. So draw the two hydrocarbons on the left with the names given, and then name the two structural formulas on the right. So pause the video and try those out. All right, so let's go over these quick and then we'll move on to today's lesson. So remember how to do these. The prefix tells you the length of the carbon chain, and the ending tells you if you're dealing with an alkane, an alkene, or an alkyne. So first thing you want to do is just draw your carbon chain. So pent is 5. Remember, we can use table P to help us out. So it's 1, 2, 3, 4, 5. And then ane tells me it's an alkane, so we use table Q there. So there's all single bonds between the carbons, so we don't have to add in any multiple bonds. And then the only other thing we have to do is go around and add in our hydrogens to make sure each carbon has 4 bonds. All right. And there we go. So that's pentane. So remember, it's an alkane, so it should be CnH2n plus 2 for the general formula. So for C5, we should be H12. And if we count up our H's, you'll see that there are 12 of them. All right, next one down, butane. But is 4 carbons. 1, 2, 3, 4. And then the YNE tells us that there's a triple bond. So for now, we're just going to put that between the first 2 carbons. And then we're going to go in and fill in with H's. So don't overdo it where there's a multiple bond. This carbon already has 4 bonds. And then these two need some more H's to give them each 4 bonds. Once every carbon has 4 bonds, you're done. All right, so this is C4. So our N is 4, and if it's an alkyne, it should be 2N minus 2. So that would be H6, and it is. All right, it matches up. All right, so now let's name these. So 3 carbons is prop, and then it's got a double bond, so that means it's an alkene, so it ends in ene. Done. All right, and your alkenes are CnH2n, and as you can see, this is C3H6. So every homologous series should always match up with the general formula, right? So, and then the last one here is C6, 6 carbons. So that's hex. All right, remember, don't have to memorize these prefixes. Look on table P, and it's all single bonds, so it's an alkane, so it ends in ane. Done. All right, so that's not too bad, but of course, as always with chemistry, things get a little bit trickier as we go forward. So let's move on to today's lesson. Today we're going to get into something called isomers. So we've seen iso before, and it always kind of means the same thing. So if we talk about isotopes, those are the same elements with a different mass. Atoms are the same element with a different mass. So something is similar with iso. So isomers, and here's the definition if you want to underline this on the worksheet. Same molecular formula, but a different structural formula, right? So that's the definition of an isomer right there. Same molecular, but different structural formula. So what do we mean by that? Well, like look at these 2 examples here. Okay. So this one has 4 carbons, so it's C4. And then if we count our H's, you'll see that there are 10 H's, all right? And we would call this butane, a 4-carbon alkane. But now this one, and we're missing some H's here, so let's add those in. Missing an H here, missing an H here, all right? So now here, again, if we count these as 1, 2, 3, 4 carbons and 10 hydrogens. So it's same molecular formula, but notice this is different structurally. It's not this single straight chain. You've got this branch here, right? And this branch we call an alkyl group. So what is an alkyl group? You need to know this term. So an alkyl group is a hydrocarbon branch off the what we call the main chain, which is just the longest chain in that hydrocarbon. Sometimes they call it the parent chain. So write this in at the top of the worksheet. Got some space there. And these are pretty simple. How do we name the alkyl groups? Well, the length of the carbon gives you your prefix, right? Your prefix off of table P, and then they just end in YL. So it's the prefix plus YL. So alkyl group. So they end in YL. So like this, look, a 1 carbon branch is methyl. 2 carbons would be ethyl. So we're just using, again, good old table P to help us out here. So again, what's the difference here? They're the same molecular formula, but they're different structurally, right? Therefore, they're going to have different properties, and they're going to have different names, right? So no two different structures have the same name. So even though these are both C4H10, one is called butane and one is called 2-methylpropane, and we'll learn how to name these today. But they're both still C4H10, so same molecular formula, but they're different structurally. This one has a branch coming off of a 3-carbon chain. All right, so this is structurally different. There's nothing I can do to bend this around to make it look like this. One thing you want to notice about these branches is, remember, think of them as kind of a fork in the road. They're always going to go off in 2 directions. So it goes this way and it goes this way, right? Something like this. You can't have a branch on an end carbon, right? I can't draw this. And then with my H's all around, I'm not going to put the H's in just to save some time. All right? So this is no good. You can't have a branch on an end carbon because it's not a branch. It's just a bend in the road. I could flip this carbon back up, bend it right up, and make this again. It's not structurally different. So a branch has to be a fork in the road. It's got to go in 2 different directions. All right, so this is no good. You can't have a branch on an end carbon. It's always got to go in 2 directions. It's got to be on what we call an interior carbon, right? The branches are always on interior carbons inside the chain. So remember that. Branches cannot be on an end carbon, right? They must be on an interior, what we call an interior carbon inside the chain. So let me show you what I mean by this. And I'm just trying to understand what these isomers are. The same molecular formula, different structural formula. So here's these ball and stick models that we would use in class if we were back in school. So this, right, this is a model of butane right here, right? It's got our 4 carbons, our 10 hydrogens, and that's butane. It's straight chain, as straight as it gets here, right? So if we were in class, we'd be able to use these and play around with these and really help understand this concept, but we'll do the best that we can here, right? So this is butane. So straight chain, 1, 2, 3, 4, right? So now understand why I can't put a branch on the end, because that would be just like if I did this. I just took it and I bent this down, right? Now, this isn't structurally different because I can just take this and bend it right back up to get our straight chain version of it. So that's not structurally different. So you can't have a branch on the end carbon. So the other one, this 2-methylpropane, this is structurally different because now I have to take it apart to make it. And I get this. So this is our 2-methylpropane. And we'll learn how this works here. All right, so it's different structurally because I can't bend this around. No matter what I do, I can't bend this around to get it back to looking like the straight carbon version of this butane, right? I have to pull this carbon off, break that bond, and move things around. So that is how we know it's not the same thing. It is structurally different, and it is an isomer, right? So now how do we go about naming these, what we call these branched hydrocarbons? So we want to get into that now, and just keep in mind that no two structures can have the same name. So every name has its own unique structure. Every structure has one name, all right? So even though they might have the same molecular formula, if they're different structurally, they're going to have different names. So let's take a look at that. So we're just going to work through this worksheet as practice, and then you can try some practice problems on your own. So step one. Step one is find the longest chain of continuous carbon atoms. So what that means is kind of think about taking the end of your pen or your pencil and just moving across without lifting it or going backwards, and seeing how many carbons can you count without lifting your pen or pencil off of the paper and going in one direction. So like, let's look at this example here. We've got 1, 2, 3, 4. Now let's see if there's other ways we could go that might give me a different, longer length of carbons. 1, so here 1, 2, 3, 4. That still gives me 4. And then what if I start over here? 1, 2, 3. That only gives me 3. All right, so 4 carbons is the longest consecutive chain. So now we want to number the carbon atoms in the chain so that the multiple bond or side chain has the lowest possible number. All right, so that's important because we don't want to just be making mirror images of the same structure. All right, so this is 1, 2, 3, 4. So if I were to number these carbons, this is my branch. So here's our alkyl group. We want to make sure our branch is on the carbon with the lowest possible number. So we want to start counting from the side that gives you the lowest number. So 1, 2, 3, 4. So I've numbered my carbons, all right? So next thing we want to do is indicate the number of a multiple bond if one is present. All right, if present, and I'll show you how that works. And then the next thing, use the prefixes, methyl, ethyl, whatever, to indicate the length of our side chain. That's an alkyl group. And we're going to give it a number. So we always give a number. So what do we have here? So our main chain is a 4-carbon alkane. So we would call that butane. And on the second carbon, we have a 1-carbon branch, right? So we would call that a methyl. We don't count the carbon in the main chain, just what's coming off of it, like the branch coming off of a tree. So we're missing our bond here. So this would be called, on the 2-carbon dash, there's a methyl group, and the main chain is butane. So this would be called 2-methyl-butane. There's a 1-carbon branch on the second carbon of our main chain, all right? So remember, we want to always start from the end that gives it the lowest possible number. So it's 2-methylbutane. There's no such thing as 3-methylbutane, right? If I drew that, 3-methylbutane, look, if I did this, I'm not going to put the H's to save time. This is no different than this. It's just a mirror image. It's if I took it and I flipped it around, right? So it's like taking your molecular structure and just flipping it around. It's the same exact thing. It's not structurally different. Remember, these are molecules. They can move, they can twist, they can turn around. So just keep that in mind. So there's no such thing as 3-methylbutane. This is the same thing as this. I would just start counting from the end. That gives me the lowest possible number, 3, 4. All right, so that's still 2-methylbutane. So the lowest possible number is important. All right, so now the next one. Let's move on. So the same, these are our 5 rules. So number 5, these prefixes, we'll talk about that in a little bit, but let's just keep it simple for now. So now here we've got 1, 2, 3, 4. All right, so this one is drawn a little bit weird here. You don't really need to think of it like that. Let's kind of straighten it out. So let's say we had, it looks like this, right? And here's our H's. I'm not going to put the H's just to save time. All right. So what would we call this? We would call this an alkyne because it has a triple bond, right? And it's 4 carbons. So it's butane. All right. But now the one thing we haven't been doing, we were doing this in the last lesson, is using that number to show location. So here is step 2. So everything needs a number because you want to be able to recreate this. So this triple bond, where does that triple bond occur? It occurs between the first and second carbon, right? Same thing. I want to start from the side that gives me the lowest possible number. So it's after the 1 carbon. So we really would call this 1-butane. Right? It's not just butane because that's not giving me enough information, because I could also draw this. Right? I could draw this. And now, where is my triple bond? It's between the 2 and the 3 carbons. So we would call this 2-butane. So because the triple bond is coming up after the second carbon. So you start counting from the end, gives you the lowest possible number, and once you hit that triple bond, you say the carbon that it appears in front of. So it would be the same thing for a double bond. Where is that multiple bond located? Because if I just tell you draw butane, you don't know what to do. Where do you put that multiple bond? But if I tell you 1-butane or 2-butane, then you know exactly what to do. And these are examples of isomers. Same molecular, different structural. They're both still C4H6, but they are different structurally, therefore they have a different name. Changing the number constitutes a different name. And now remember, there's no such thing as 3-butane because it's the same thing as 1-butane. It's just taking it and flipping it around, all right? So just keep that in mind. Think about these things as we're going. Always start from the end that gives you the lowest possible number, all right? So let's take a look at these two, and then we'll do some examples here. So now this one will be 1, 2, 3 carbons, and we have a double bond, so we know it's an alkene. So it's going to end in ene, so it's propene. Right? That's it. And now where is that double bond? It's after the 1 carbon. So this is 1 propene. So now technically though here, sometimes if the chain is really short, you don't need the number. But when in doubt, just put the number. That's kind of a safe bet here. If you leave the number out and you need it, it's going to be wrong. So because I could just call this just propene, right? Because no matter where I put that double bond, if I put it over here, it's still, right? It's still 1 propene, because we would start from the end that gives us the lowest possible number. So the double bond can't appear anywhere but after the first carbon. So the number is kind of unnecessary. But if you put it, that's fine. All right. But just keep that in mind. Sometimes when the chain is really short, then you don't really have that many possibilities, so you may not need the number. So now let's look at this one. All right, let's find our longest consecutive chain. 1, 2, 3, 4, 5, 6, 7 carbons. Okay, so let's check if we go down this fork in the road. 1, 2, 3, 4, 5, 6. No good. So 7 carbons is our longest consecutive chain. And now we want to start from the end where the branch, so here's our branch, right? That's our branch. It's a 2 carbon branch. So remember, we would call that ethyl. So that's an ethyl branch. So now where is it? Well, starting from which end will give us the lowest number? 1, 2, 3, 4. 1, 2, 3, 4. So either side, we end up with 4. So we're on the 4th carbon. So we can start from either end, right? So 1, 2, 3, 4, 5, 6, 7. So this would be 4 ethyl, and then 7 carbons is hept, and it's an alkane, so it ends in ane. So it's 4 ethyl heptane. Done. Right? So it seems a little confusing, but it's really pretty simple. It's telling you exactly everything you need to know. On the 4th carbon of a 7 carbon chain, there's a 2 carbon branch coming off of it. Done. All right? So now, if this branch were coming out of the top of the main chain, it would still be the same thing. It's just taking it and flipping it over. So think about that, about flipping it or turning it or whatever. Is it really structurally different? All right. So just always keep that in mind as you're going through this stuff. So it's 4 ethyl heptane. So let's keep going. Let's move on to drawing these when I give you the name. Sometimes I think that's easier and it helps you out with being able to name them when given the structure too. So think about what's going on here. So let's take a look at the first example here, 2-methylbutane. So easiest way to do these is to just first draw the main chain, butane. So it's a 4-carbon alkane. That's easy. 1, 2, 3, 4. So now what do we do? Well, it's telling us exactly what we need to do. On the 2nd carbon, we're going to put a methyl, a 1-carbon branch. So 1, 2, I'm going to go right here. Doesn't matter whether you go up, down, whatever. And just to save time, I'm going to leave off the H's, but make sure you draw those in. So there we go. That's it. All right. So that's 2-methylbutane. So let's put our H's in just so you can see them. All right. So that's 2-methylbutane. Now, if you were to take that methyl group and put it down here, that would be fine, right? And also remember, if you were to take that and put it on this carbon, that doesn't make it 3-methylbutane. It's still 2-methylbutane, right? There's no such thing as 3 because we always want to give it the lowest possible number. And we can't put that on the end because then that would just bend right back up to the straight chain. So let's look down at the next one. 1-butene. So ENE tells me it's an alkene, so we've got a double bond. So bute is 4 carbons. Draw your 4 carbons. All right. Now, where do I put that double bond? Well, it tells you exactly what you need to do after the first carbon. So after our first carbon, we put another bond, and then we put our H's all around. Make sure we're only giving each carbon 4 bonds, right? It's easy to overdo it. Stick another one in here. This one needs another H, and we're good. So that's 1-butene, right? Because we can also have 2-butene. Can't have 3-butene because that's just 1-butene all over again. It's just taking it and flipping it, right? So take a second, pause the video, and try these next 2 out on your own. Don't move past this, but just try these 2 out quick, okay? And then unpause the video, and we'll see how you did. All right, so first thing, we draw our main chain, pent. 1, 2, 3, 4, 5. And then on the third carbon, there's a 2-carbon branch. Up, down, wherever you want to go, that's fine. And then put your H's, right? I'm just going to show the bonds and leave the H's off, like I said, just to kind of save time. But make sure each carbon has 4 bonds coming out of it, right? And that's it. So, and again, if you put this ethyl group coming out of the top, that's fine. But you can't have it split going between, like 1 carbon up here, 1 carbon up here. That's no good. Think about a branch. It's a branch coming out of one side of the tree, right? A branch doesn't split through the tree. It comes out of one side. So same thing here. Your branch has to come out of one side of the chain. You can't have 1 up here, 1 down here, and 1 up here. Doesn't work like that. That would be 2 separate methyl groups. So this one, hexyne, hex is 6 carbons. 6 carbons. And then the YNE tells me it's an alkyne. Where do I put that triple bond? After the third carbon. 1, 2, 3. So we put it right here. And then put your H's all around. Remember, don't overdo it. These 2 carbons are done. They already have 4 bonds. And then we'll finish these up. And that's it. All right, so that's 3-hexyne. So now, next thing. What does this mean? This di. So that's on our rules. So if we look back at our rules and look at rule number 5, it says we can use these prefixes, di, tri, etc., for multiple side chains of the same length. So again, drawing it really helps understanding, and it makes it easier to name when given the structure. So let's take a look at this. So 2,3-dimethylhexane. So let's keep going the same way we've been doing. First thing we want to do is draw the main chain, the parent chain, hexane. 1, 2, 3, 4, 5, 6. Hex. Now, there are 2 methyl groups. That's what the di means. There's 2 methyl groups. So where do I put them? Well, it tells you exactly where to put them. One's on the 2 carbon, one's on the 3 carbon. So whichever side you start counting from, you have to be consistent with your numbering. If I start counting here, then 1, 2, 3, 4, 5, 6. This is my 2 carbon. This is my 3 carbon, right? I can't do 1, 2, and then 1, 2, 3. Wherever you start counting, once you've numbered these carbons, so even if you want to write in numbers for them, those numbers are set. You can't change those. So 2, 3 means on the 2 carbon, I put a methyl. And then on the 3 carbon, I put a methyl. Doesn't matter whether you go up, down, as long as they're on the appropriate numbered carbons of the main chain. And then we put our H's all around. Don't forget all your H's. Each carbon needs 4 bonds. And there you go. This is 2,3-dimethylhexane. There are 2 methyl groups. one's on the 2 carbon and one's on the 3 carbon of a 6 carbon alkane. That's it. So why don't you try drawing the other 3 on your own? Pause the video, give those a whirl. Draw the main chain first, and then put your branches in the appropriate place. All right, so let's take a look at these. 2,4-dimethylheptane. So we draw hept. 1, 2, 3, 4, 5, 6, 7. 7 carbons. On the 2 carbon, I'm going to start from the left. 1, 2. There's a methyl group. And then on the 4 carbon, there's a methyl group. Now we put our H's all around. And we're done. So this is 2,4-dimethylheptane. Methane, that one should be pretty simple. 1 carbon is meth, and then you just put 4 H's. CH4. Right, that one's easy. It's just 1 carbon, meth. And now the last one, 2-methyl-3-ethyl pentane. So now we have multiple branches, but they're different lengths. So we name those separately, and the number tells you exactly where to put them. So pentane, 1, 2, 3, 4, 5. And this is telling me on the 2nd carbon, there's a methyl group. On the 3rd carbon, there's an ethyl, 2 carbons, F group. Put your H's. So remember, if we don't put the H's, we at least have to show the bonds. So every carbon needs 4 bonds coming out of it, right? We can assume that these open-ended bonds are H's when we're dealing with organic chemistry, but on a quiz, test, whatever, you want to make sure that you put the H's so that it's clear that you're showing those hydrogens bonded. But to speed things up, we can leave them out for now. So this is 2-methyl. On the 2 carbon, there's a methyl, 1 carbon, 3-ethyl pentane. So that's it. It's really not that bad. It looks a little confusing, but make sure you just do your practice and work at this, and it should get a little bit easier as you move forward. So now the last thing, which members in the above diagrams are isomers? So same molecular, different structural formulas. So, and if they're different structurally, they're going to have different names. So let's go back and look at the molecular formulas. So remember, when we're counting the molecular formulas, you want to make sure you're counting all of your atoms, not just the ones in the main chain. So this isn't just hexane. There are 1, 2, 3, 4, 5, 6, 7, 8 carbons. So this is C8, H18. Right? If we count all our H's, you'll see that there are 18 of them because it's still an alkane. So it's still going to be CnH2n plus 2, but you want to make sure you count all of your C's and H's, not just the ones in the main chain. Right? You can even, if you want, just add up your prefixes. So di means there's 2 of them, 2 methyls, that's 2 carbons, plus a hex, 6. 6 plus 2 is 8. Right? So that gives us C8. And if we know our N, you can figure out your hydrogens using your general formulas. Right? So let's go over here. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is C9H. What would that be? 2N plus 2, because it's still an alkane. 20. So that's C9H20. Again, hept 7 plus 2 methyls is 9. So you could always add up the prefixes as well. All right, this one's easy. This is just CH4. And then this one, 1, 2, 3, 4, 5, 6, 7, 8. This is also an alkane, so it's C8H18. So here you go. These 2 are isomers, right? These are my isomers. They're the same molecular formula, but they're different structurally. So, and again, we have 5 plus 6, 7, 8. 8 carbons. So our isomers were our C8 H18s, right? These are two isomers, same molecular formula, but they're different structurally. So different that they have different names, right? That's what it means to be structurally different. You're going to have a different name. So this topic's not too difficult, but it may take a little bit of time to get the hang of it. So you really want to make sure you're doing any practice problems that I give you. The more problems you do, the easier this topic will get. So that's it for today. I'll see you all next time.